Can you give a short introduction of yourself and the subjects that you have prepared for the interview?
Uh, I'm Arvind Chauhan sir. I am from Gazipur, Uttar Pradesh. I have done my graduation from NIT Srinagar in chemical engineering by Harvard traveling sir.
What did you say at the end?
By Harvard traveling sir.
Okay, you like to travel. Good. Where have you been to? The places.
Sir, Rajasthan, Uttarakhand, Himachal Pradesh, Jammu Kashmir, Srinagar, Palgam, Sonmarg, Gulmarg.
Oh, that's cool.
Mumbai.
And which is your favorite one?
What is
Which
Kashmir sir?
Kashmir. Okay. And any dream place to visit?
Yes sir.
Any dream place to visit? Like, yes, I want to visit this place. Maybe in India or abroad.
Dream place sir. Uttarakhand sir. Oh, Uttarakhand, Haridwar.
Okay, good, good. So, what are your favorite subjects?
Sir, chemical reaction engineering, CRE, heat transfer and fluid mechanics.
Okay, cool. So, let's start with heat transfer, I would say.
Yeah.
So, I'll ask you this question. So there is a rod, it is heated. Okay. Now it has been placed horizontally. You have case A, case B. Okay, it's all natural convection only. So in case A, it has been placed horizontally in an air, and in case B, it has been placed vertically in air.
Yes, sir.
So what can you comment about the heat transfer that is happening in case A and case B? Case A is horizontal, case B is vertical. It's a rod, that's a metal rod having a constant temperature throughout its surface.
Yes, sir.
So what can you comment about the heat transfer here? So there will be convection going on, right?
Yes, sir.
Correct. Now, which type of convection is this? I
So
told you
natural
initially.
convection. Natural
Correct. There is
convection.
no flowing air that has been given. Correct.
Yes,
So
sir.
okay, I'll make the question even more you can say direct. So which one of these will give me a higher heat transfer result? Which one will execute a higher heat transfer? There is a
सर जहाँ पे
horizontal. Uh-huh.
सर
The
जहाँ
horizontal
पे
rod.
टेम्परेचर ड्रॉप ज़्यादा होगा वहाँ पे हो सकता है, जहाँ पे हीट ट्रांसफर कोएफिशिएंट ज़्यादा होगा, दो तरीके से हो सकता है ज़्यादा.
No, now heat transfer. See, metal is same, the surrounding is same, everything is same. The
Yes,
only
sir.
difference is in case A it's horizontally placed, in case B it's vertically placed. So which one will have higher heat transfer, if any? I mean, or do you think both will have same heat transfer?
सर वर्टिकल में ज़्यादा होना चाहिए.
अच्छा, क्यों? अब ज्यादा बोला है तो क्यों का आंसर भी देना पड़ेगा.
क्योंकि सर जो मालिक्यूल प्लेट पे रॉड पे आएंगे सर, अगर रॉड गर्म है तो सर ऊपर जाएंगे ड्यू टू ग्रेविटी, फिर नीचे चले जाएंगे, तो मालिक्यूल्स का एक करंट बना लेंगे सर.
Your answer is correct, but not like very exactly what we want or what is expected. You are right. You are right. Molecule ऊपर जाएंगे. You are right. But they नीचे आने का part you can just leave it away. Can you think with this ऊपर जाने वाले part? You are right.
Yes, sir.
You are right. Think more.
सर ऊपर पार्टिकल जाएंगे सर, वेलोसिटी का भी रोल आ जाएगा वहाँ पे। वेलोसिटी
करेक्ट
ज़्यादा होगी तो सर हीट ट्रांसफर कोएफिशिएंट बढ़ जाएगा सर, तो हीट ट्रांसफर रेट बढ़ जाएगा।
करेक्ट करेक्ट सो व्हाट एग्जैक्टली हैपेंस इज नीचे के जो फ्यूम्स है वो ऊपर जाएंगे एंड ऑल्दो ये केस नेचुरल कन्वेक्शन का है फॉर द टॉप पार्ट ऑफ द रॉड इट विल बी अ काइंड ऑफ अ फोर्स्ड कन्वेक्शन ऑल्दो देयर इज नो इंड्यूस्ड एयर फ्लोइंग but due to the air is rising up it will kind of execute a forced convection. You are right. Yes, so this is what was expected. Take one more conduction question, I would say. So what would you do if what is the law of conduction in formula? Can you give me the formula?
फोरियर लॉ ऑफ कंडक्शन
Correct.
जो कि कहता है सर हीट फ्लक्स इज डायरेक्टली प्रोपोर्शनल टू टेम्परेचर ग्रेडियंट।
Correct.
जितना ज़्यादा ग्रेडियंट होगा उतना फ्लक्स में मिलेगा सर।
Right. Now can you formulate can you formalize it?
QS इक्वल टू माइनस के dt बाई ds, वेयर के इज द थर्मल कंडक्टिविटी सर।
Correct. Now what if area is you can say not a constant? What will you do?
फोरियर लॉ में सर एरिया कांस्टेंट है, परपेंडिकुलर एरिया लेते हैं डायरेक्शन ऑफ फ्लो के।
Correct. So what if there is rod, because kind of cylindrical rod, but the area is increasing as we go along the length.
यस सर।
So can you still use the formula, or is there some another formula for the same? Now you want to find out what is the heat transfer.
सर डिराइव कर सकते हैं?
Yeah, go ahead.
सर एरिया तो लीनियर वेरी करेगा ना सिलेंडर में?
क्या लगता है?
Let it vary in any way. That should not matter for your derivation.
Right.
सर ये तुम्हारा तो ऐसा आएगा सर।
What's the last term? dA by?
सर लास्ट टर्म d2t बाई ds स्क्वायर सर आ रहा है।
Okay, fine. Can you draw the you can say the temperature curve here from left to right? What will be the temperature? Consider that area is increasing linearly, for example.
Okay, sir.
And what were the other subjects that you talked about?
Sir, CRE and flow mechanics. सर अगर लीनियर वेरी कर रहा है तो टेम्परेचर प्रोफाइल तो सर लॉगरिथमिक आ जाएगी सर। तो
हाँ ठीक है, तो ड्रॉ करो।
सर इस तरह से आना चाहिए।
अच्छा, from left to right, which one has a higher area here, the left side or the right side in your curve? in your curve, the left side has a higher area or the right side has a higher area?
Right side, sir, higher area, sir.
Right side higher area. Okay. Can you comment about the gradient of temperature based on the area?
सर जिधर एरिया ज़्यादा है सर वहाँ पे ग्रेडियंट कम होगा सर, जिधर एरिया कम है वहाँ पे ग्रेडियंट ज़्यादा होगा सर, क्योंकि
Correct.
क्यू तो
Now
सही है सर.
correct. Now can you redraw the curve? Because in your curve, it was appearing that the temperature is kind of linear. Can you, I mean, draw it again? Your curve is right.
सर यही होगा ना?
कौन सा राइट वाला लेफ्ट वाला? ठीक है. Now very clear. ठीक है. नचिकेता?
Yeah. So we'll continue with your first favorite subject, that's theory. Okay.
Yes, sir.
Now, can you tell me what is an elementary reaction?
सर एलिमेंट्री रिएक्शन उन रिएक्शन कहा जाता है जो सर सिंगल स्टेप में कंप्लीट हो जाती हैं सर, और जिनका रेट सर उनके मॉलिक्यूलरिटी के प्रोपोर्शनल में होता है सर.
Can you write it down mathematically? Like how will the rate will be defined for an elementary reaction? You can take the reaction as AA plus BB gives CC plus DD.
क्या सर रिएक्शन बोलिए?
Small a times capital A plus small b times capital B giving CC plus DD. हाँ और थोड़ा ऊपर करो अपना. Is it like this? Do you think you have written the rate correctly? Okay, what will be the equilibrium constant for this reaction?
इक्विलिब्रियम कांस्टेंट सर और कंसंट्रेशन के सर टर्म में.
हाँ. Let's say that reaction is reversible. So equilibrium constant.
सर ये होगा.
टी-शर्ट के पास नहीं दिख रहा, चेहरे से हटाना या फिर अपना बैकग्राउंड हटा देना. अब उस पेपर को थोड़ा ऊपर करते हैं. ओके 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 फाइन फाइन. Right. Okay. Now, if say I have A in stoichiometric, let's say A is limiting reagent, okay, and B is in
Yes.
X. So, in the rate log is the same or there can be some modifications in
सर एलिमेंट्री रिएक्शन है ना?
elementary reaction. It's just that I have too much of be in the reaction mixture, matlab way too larger than stoichiometric ratio. Let's say A is 1 and B is 1, and I have 10 times larger B in the reaction mixture. So will the rate still be a function of B, or so how will be the rate expression for this?
सर सेम नहीं होगा, क्योंकि जो कम होगा ना उसके रूप में रेट आता है सर, जो कम से कम होता है। तो बहुत ज़्यादा करनी है तो उनका कांस्टेंट लेके अलग कर सकते हैं सर, उस पर डिपेंड नहीं करेगा।
कैन यू राइट दैट एक्सप्रेशन?
यस।
And you need to have some K dash, right?
Yes, sir.
Okay, you have done that K dash. Okay, great. Now, this was for a homogeneous reaction.
Yes,
now,
sir.
let's say I have a heterogeneous reaction where my reactants are in gaseous phase, and it's a catalyzed reaction, and my catalyst is in solid phase. So, what are the two different, what I can say, expressions or laws that are used to define the rate expression?
लॉस तो नहीं पड़े सर, लेकिन दो इसे एक रिएक्शन पाई जाती है, एक मास ट्रांसफॉर्मर में होता है सर।
Right. So if you just start writing them, let's say A is giving B, is the reaction occurring? Okay. Now, can you tell me what are the different mechanisms for it? Or say reaction is A plus B gives C.
Yes, sir.
There are two different ways to write the rate expression. One, I'll give you a hint. One is Langmuir.
Yes, sir. वो लैंगम्यूर और हिंसलबर्ग कुछ रिएक्शन के टाइप होते हैं सर वहाँ पे। तो सर फाइनल एक्सप्रेशन तो सर याद है, मतलब कैसे होता है पता नहीं है।
फाइनल एक्सप्रेशन लिख दो एंड मे बी वहाँ से यू कैन आंसर माय क्वेश्चन। हाँ,
शायद इसी तरह से कुछ एक्सप्रेशन सर आते हैं।
थोड़ा सा अपने शर्ट के पास ले लो पेपर। हाँ, एक्सप्रेशन तो फाइनल इसी टाइप के आएंगे, दैट इज ऑल राइट, बट यू नीड टू टेल मी द फंडामेंटल डिफरेंस बिटवीन एलिरिडियल एंड लैंगम्यूर हिंसलबर्ग।
इसमें शायद सर एयर जॉब होने की बात होती है, मतलब ए सी पे एयर जॉब हो रहा है कि नहीं, बी सी पे एयर जॉब हो रहा है कि नहीं, मतलब इसके दो इस पे बात होती है।
राइट, तो एलिरिडियल में क्या होता है? वी हैव टू रिएक्शन, लेट्स से A plus B giving C. Okay, so what will happen in एलिरिडियल?
एलिरिडियल सर सी पे एडजॉर्प्शन होता है सर, ए और बी दोनों का सर।
A will get adsorbed, B will react with adsorbed A and form the product. Okay. Whereas A plus B gives C is the reaction that we are looking at. Okay.
Yes.
So if we are talking about Langmuir, then A should get absorbed with the site to form AL. B should get adsorbed with the site to form BL. AL plus BL will react. Okay. And then there will be a product, and then that product will be dissolved. Okay, so we will have mechanisms in that way, whereas in eLiridial only one species should get adsorbed. So let's say A got adsorbed, B got reacted with the adsorbed species, and directly the product C was formed. So that is the difference between eLiridial and Langmuir Hinshelwood mechanism. Okay. So we'll have last two questions on CRE, and then we'll close. So now talking about Langmuir, can you tell us more about the Langmuir's law of adsorption?
सर ये वाला पार्ट कंप्लीट नहीं है सर, हेटेरोजेनियस वाला सही से।
then I have I have
Nachiket, you are not audible clearly.
okay. Hello, am I audible now?
Cool, cool, cool.
Yes, sir.
Okay. So I was just saying that Langmuir adsorption also comes in mass transfer. Okay, it's a law of adsorption, so you can correlate things from there as well. But anyways, we'll now go to fluid mechanics. Okay, let's say I have two concurrent pipes and fluid is flowing through the annulus region.
Yes, sir.
Can you tell me the velocity profile of the fluid? And while going towards the velocity profile, can you first describe what are the boundary conditions and assumptions that you are making to get that particular profile?
सर क्या न्यूरिया स्टोक से निकाल सकते हैं क्या वेलोसिटी प्रोफाइल?
हाँ?
न्यूरिया स्टोक से हेल्प से निकाल सकते हैं वेलोसिटी प्रोफाइल इसमें?
इससे?
न्यूरिया स्टोक से?
हाँ, you can take that. Yeah.
Can, but थोड़ा complex हो जाएगा मतलब.
Maybe हाँ मतलब आप ले सकते हो. आप you don't need to actually solve all the equations. You just need to make the graph. ठीक है? And while making the graph, you can just tell that ये assumption था इसलिए graph का nature ऐसे ऐसे आया. If you try to solve it entirely mathematically, it will take you a lot of time.
Just draw the graph and explain why is it like that.
सर इस तरह से आएगा क्या?
Just lift it up. Cannot see anything. What you can do is you can just remove the. अच्छा, you are drawn two parabolas, हाँ?
सर बीच वाले में पैराबोला है सर और आउटर सर्फेस पे लीनियर ड्रा किए हैं सर.
The fluid is only flowing through the annulus region.
एनुलस में सर तो पैराबोला आए सर लीनियर आएगी ना?
अच्छा, let's say linear है. Okay. So what happens at the extreme end and what happens at the inner boundary? Can you explain the boundary condition? Why it is a linear? That's why I said you should start with boundary condition and assumption and then make a graph. First
Sir,
of all, tell me what is the annulus region.
सर सरफेस पे तो वेलोसिटी 0 होगी सर.
Correct. So can it be linear when there are
जो
surfaces?
और सर जो इनर पाइप है सर उसके सरफेस से वेलोसिटी 0 हो जाएगी क्योंकि वो सरफेस मूव नहीं कर रहा है.
Correct.
तो उसी तरह मतलब दोनों तरफ बनेगी इनरल में और बीच वाली पाइप तो सबसे मूव तो उसमें पैराबोला ही बनेगा.
उसमें कोई फ्लूइड फ्लो नहीं हो रहा है. फ्लूइड इज ओनली फ्लोइंग थ्रू द एन्युलस रीजन. मतलब दो पाइप के बीच का जो एरिया है सिर्फ वहीं से फ्लूइड फ्लो हो रहा है. ओके.
तो सर पैराबोला ही बनना चाहिए तब. दो
करेक्ट. इट शुड बी पैराबोला.
दो पैराबोला बन जाएगा, एक ऊपर एक नीचे वाले साइड में.
करेक्ट. Now tell me, are those two boundary conditions sufficient to solve the problem, or you need more boundary conditions?
सर अगर जैसे वेलोसिटी प्रोफाइल निकालते हैं वहाँ पे अगर दो कांस्टेंट आ जाते हैं तो दो हमको बाउंड्री कंडीशन चाहिए होगी. दो तो मिल गई सर.
हाँ, दो मिल गई है. You are right, but so you think it is enough to solve the problem?
वेलोसिटी प्रोफाइल तो हम निकालेंगे सर वहाँ से, तो हाँ आई थिंक सर सफिशिएंट है, निकाल सकते हैं।
ओके ठीक है। Now what if I make this pipe vertical?
यस सर।
What if I make this pipe vertical?
यस सर। सर वर्टिकल है सर, तो ग्रेविटी फोर्स भी एक्ट करेगा सर यहाँ पे।
राइट।
वेलोसिटी प्रोफाइल सर, तो वही सर सरफेस पे जीरो हो जाएगी सर, कि सरफेस मूव कर नहीं रहा है, तो रिलेटिव वेलोसिटी तो जीरो हो जाएगी सर, दोनों सरफेस वही बनेगी, लेकिन बस एक ग्रेविटी का रूल आ जाएगा सर उसमें।
ग्रेविटी से क्या इफेक्ट आएगा?
बाउंड्री लेयर सर जल्दी डेवलप हो जाएगी सर।
ओके ठीक है। मोस्टली जैसे जैसे फ्लूइड ऊपर जाएगा उसकी वेलोसिटी कम होते जाएगी, दैट इज वेरी ऑब्वियस वन। बाउंड्री लेयर का उतना ये नहीं आएगा बिकॉज वी आर इनटू लैमिनार जोन इटसेल्फ। बाउंड्री लेयर का उतना कंसर्न नहीं आएगा। इफ यू आर टॉकिंग अबाउट एंट्री लेंथ मे बी, बट रेस्ट इट विल बी जस्ट द सेम, उतना ज्यादा डिफरेंस आएगा।
जैसे सर फ्लो सर नीचे से ऊपर जाएगा तो सर उसको डेवलप होने में थोड़ा सा ज़्यादा लग जाएगा ना, मतलब, और ऊपर से नीचे आएगा तो जल्दी डेवलप कर जाएगा।
No, what we are talking about here is a already developed flow, fully developed flow.
ओके सर।
Okay, so we are not talking about, let's say, entry length or something like that. That will make the problem extremely complex, to be honest.
Yes.
Okay, so yeah.
All right, then we'll stop your interview here. Okay.
Yes.
Now I will first give the comments for you, and then Arun is not here. So for you, I think you should learn more about CRE in HeadCAD, heterogeneous CAD. Okay. And there are some topics that are common in CRE and mass transfer, like Langmuir adsorption isotope, Friendlich isotope, right? So just know what is the isotope, okay, how it has come, so that it will help you in answering your CRE questions, right? You should just know a little bit about LA radial and Langmuir Hinchelwood. Apart from that, for autocatalytic reactions and for enzymatic reactions, there is one more mechanism. If you remember, you need to ready that as well, because I see you are planning towards taking CRE as one of your favorite subjects or first favorite subject in your interview. So there is a chance that they can ask you questions on this, right? You should also prepare on topics like half-life and more about zero-order reactions.
Yeah, so you were very direct with the questions and answers, very prompt with them. I like that. As in, whenever a question is asked, you always have something to give as an input. That's a nice thing to have. You know, then the interaction between the interviewer and the candidate, that keeps going on. Though your conduction convection is also good. Though one thing I would suggest is, see, when you go to interview, you will always have to draw lots of diagram. So try to draw your diagram carefully and with as much details as you can. So although I can understand we are having an interaction in online way here, but still it will be more or less same in the in-person interview as well. You will have to draw the diagram, you will have to explain them. So whenever you draw a diagram, detailed it. For example, T1 and T2, then T1 is greater than T2. You should mention that in the diagram itself. You know, it gives a more thought on your clarity about the question. For example, if you remember at the end, at the top you drew the actual physical diagram, and then you draw the temperature diagram. Remember? And just using looking at that, I can understand. Yeah, that so you are also giving me a little backstory of the problem. So that was actually very impressive. But before that, you were just going on drawing the diagram, and it was little confusing for us as well. Okay. So when you draw a diagram, mention the details in it. Okay, because I know that most of the questions usually come to diagram itself in interview. They will always ask you to give, let's say, velocity diagram or temperature profile, something like that.
Yeah, that's a nice way to, and also try keeping labels for the axis. Okay.
Yes.
Because sometimes they will not ask you, but then they may confuse you after some point of time. I have this personal experience. I drew a particular diagram, and then we changed the subject after some time in the interview, and I drew a diagram which was roughly of similar nature. Okay. And in both the diagrams, I had missed out on writing the labels. Now they just confused me whether they asked me, and I also got confused whether this diagram is for heat transfer or this diagram is for CRE. If you see the diagram, that exponential decrease, that is also true for a particular chemical reaction, right? That diagram also comes very close for a CRE problem. Now, after some point of time, you yourself will get confused whether this was the diagram or that was the diagram. Better to label the axis as well. Okay. These are small things that will help you get a better position in the interview. Okay. All right. So we'll close this session and we'll meet next week.
Thanks.
Yeah, sure.